Okay, let's look at this first question. Find the area under the curve y is equal to x squared plus 4 between x is equal to 1 and x is equal to 3. So that is giving us our bounds. So we're going to be from -1 to 3. So that's going to be our lower limit of integration and our upper limit of integration. So this diagram, when we don't have our calculators, you just need to look at this diagram. It is a quadratic that is opening up because the a value is positive and it has a y-intercept of 4. So let's draw what this function would look like. So it has a y-intercept of 4 and it is opening up. So this is what my sketch of f of x would look like. And they want me to integrate, so find the area between the curve and the x-axis from -1 to 3. So from -1 to 3. Okay, and so we're finding this area here. Now, as I previously mentioned, when we integrate, the previous lesson we were doing net area, but we actually want to give our answer as total area. Do I have to worry about, for this question, any negative area for this one? No. So I could use my calculator for this question, and the answer that would come out on my calculator if I integrated this would give me the actual answer because there is no negative area here, so I don't have to worry about the signed area. Okay, so let's figure out how we would write this. So the area under the curve, we are integrating our function from -1 to 3, and we are integrating 2x squared plus 4, integrate with respect to x. This is equal to, so let's use the same notation that we did last time. So let's take the antiderivative or integrate 2x squared. That would give us 2x to the 3 divided by 3 plus 4x. Now remember, when we are dealing with a definite integral, so a definite integral is when I give you the lower and upper bounds of integration, we do not need to put plus the constant of integration because it will cancel according to the fundamental theorem of calculus. So we're going to be integrating from -1 to 3. Now, according to the fundamental theorem of calculus, this is equal to f of b minus f of a, and that is going to be equal to f of 3 minus f of -1, and that is equal to, so f of 3, I'll actually set it up, 2, 3 cubed over 3, because I'm just going to cancel that, plus 4 times 3 is 12, minus f of -1. So -1 cubed will give me a negative number, so -2/3 minus 4. Okay, I'm going to cancel that 3, and I'll change that to squared. So 9 times 2 is 18, and 18 plus 12 is 30, minus, it was 3 cubed, but instead of doing 27 divided by 3, I just used exponent laws over here. Does that make sense? So I had 3 cubed. I could have done 27 divided by 3, or just to make the math a little bit easier, I canceled this 3 and changed that to squared. 3 squared is 9. 9 times 2 is 18. 18 plus 12 is 30. Is that what you got? Okay. Minus, let's get common denominators here. So -2/3 minus 12/3 is -14/3. So this gives me 30 plus 14 thirds. And then we'll get common denominators here. So we'll get 90 thirds plus 14 thirds will give us 104 over 3. And then remember that this is area, so they don't specify, but it would be units squared. So I'll just write that down because it is area, units squared. Do you have your calculators? If you have your calculators, let's just verify. Do you want to? Yes. Yes, that's right. And don't worry if you don't. Okay, so where was it? Where do I go? So math 9. We're integrating from lower limit of integration is -1, upper limit is 3. The function that we're integrating is 2x squared plus 4, and we're integrating with respect to x. So I get that answer there. And we got 104 divided by 3. So same answer. Calculator won't give us an issue because our area was above the x-axis, so we don't need to worry. But let's look at our next example. Class example 2. Determine the area of y is equal to x squared minus 16 between the roots of the function. So let's draw this, a parabola opening up with a y-intercept of -16. So here's my y-intercept of -16, and my parabola is opening up. It wants it between the roots of the function. So the equation is y is equal to x squared minus 16. Basically, I want the x-intercepts of this function. So I'm going to set my equation equal to 0. And then I am going to factor. This would be a difference of squares. And I will get x minus 4 and x plus 4. So the x-intercepts, or the roots of this equation, are going to be plus or minus 4. So this is 4, and this is -4. Okay. Now, determine the area. So it's, remember your area that you're calculating, it's between the curve and the x-axis. So you'd have to illustrate this on your exam, and then you highlight the area. So the area that we're finding between the roots of the equation would be this area here. Everything is below the x-axis. So because they use signed analysis, it's going to give us a negative answer. So basically, what do you think we're going to do to our answer if I want total area? So if they say, let's say this is -15 units squared, what answer would I want? 15 units squared. So what you need to see from this is if it's just negative area, you're giving the absolute value of your answer, or you're putting a -1 in front of whatever your answer is. So if this was -15, if we put a -1 in front of our integral, we're going to get +15. So how are we going to write this? Okay, so the area that we're getting is going to be from integrating from -4 to 4. Okay, so between the roots of our function would give us the interval from -4 to 4. So that would give me my a value and my b value. The function that we're going to integrate is x squared minus 16. Integrate with respect to x. Okay, this will give us x to the 3 over 3 minus 16x and integrate from negative 4 to 4. So you guys, here's what's happening. Look at how I set up this interval, or the integral up here. I know that it's negative area. So what I'm going to do is I'm going to put a negative in front of the integral. Because whatever answer I get, I'm going to multiply it by negative 1 to get my positive answer. Okay, so with this function here, again, I'm going to put my negative in front. Or you're basically taking the absolute value of your equation. Or of your answer, sorry. Okay, so from here, it's going to be f of b minus f of a. And that's going to equal to f of 4 minus f of negative 4. 4 cubed is 64. 16 times 4 is 64. Minus, and then we're going to do f of negative 4. So negative 4 cubed will give me negative 64 over 3. Negative times a negative will give me a positive 64. Don't worry about getting common denominators here, and I'll show you why. You're going to hope that something will cancel, and will it cancel? So let's actually just get rid of our, maybe they won't, but let's see. So 64 over 3 minus 64. Distribute that negative in. I guess that will give me plus 64 over 3 minus 64. Okay, so let's add our two fractions together. And we're going to get 128 over 3. Negative 64 minus 64 is negative what? 128. Now I guess we would get common denominators from here. So you would times this by 3 and this by 3. I'll give you what the final answer is. This final answer would give you negative 256 over 3. Yes. Yep. Yes. Okay. So I put it in here to show you that we recognize here that we're going to get a negative area. So what I'm going to do to my answer is one of two things. I'm either going to, into my answer, put a negative right now at the very end. I'm going to multiply it by negative 1, which will give me a positive value. Or I could take the absolute value of this. But you're right. I kind of have been ignoring that negative throughout. So like basically, to keep that negative inside, I would be doing this. So I'm following the negative through here. Yeah. So the negative here, this answer, negative. And then my final answer, I'm going to multiply it by a negative 1, which will give me an area of 256 over 3 units squared. So let's check that one on our calculator. So math 9. So we're integrating from negative 4 to 4. And our function was x squared minus 16. Oops. Oh, I don't know why I'm here. So our calculator gives us a negative answer, but we know based on the graph that our total area would be the positive value or the absolute value of that answer. Okay, now here's where your calculator, things will sort of fall apart unless you could see the diagram, and it will be through this one. So this question here, we're going to get a totally different answer if we use our calculator for this one. So what I want you to draw is I want you to draw this graph, x cubed, and then see if you could figure out the area from -3 to 2 and what's happening. So the graph of x cubed would be, this is the graph of y is equal to x cubed. It wants the area from -3 to 2. So the area that we are calculating the total area would be this piece of the graph and this piece of the graph. If we integrate from -3 to 2, are we going to have an overall net positive or negative area? We're going to have an overall net negative area. Now, we can't do what we did in the previous example and take the absolute value of it. What we have to do is we have to set this into two separate integrals. We're going to figure out the area of this piece, and then we're going to add it to the area of this piece. I know that this piece will give me a negative area, so I'm going to set a negative in front of this integral. We're going to set this into two separate areas. Okay, so how we're going to do this is as follows. So the area total, so let's just write area total, it's equal to, I'm going to integrate this piece of the graph here. So how I would set that up is I'm going to integrate from -3 to what number? To 0. I'm going to integrate from -3 to 0. And what I'm going to do, yeah, let's write what we're integrating. So we're integrating x cubed with respect to x. Now I know that this will give me a negative area. So I'm going to put a negative in front of here to give me the total positive area. And then to this, I'm going to add, I want to figure out the area of this region. So I'm going to integrate a keel, what would my lower and upper bounds of integration be for this one? 0 to 2. What I am integrating is x cubed with respect to x. I know that that's going to be positive area here, so I don't need to worry about changing anything. Yes, you have to do it like this when you have a positive and negative piece. Okay, so I know that it's going to be, so area total. So this is going to be negative. And then I'm going to do f of b. I'm just going to jot it above. F of b. Now b is 0 minus f of a. So for this integral, I've got my negative in front. F of 0 is just 0 minus f of -3, negative, oh, no, I forgot to take my, I forgot to write it with, so area total is equal to, so I forgot to do this. So it'd be negative x to the 4 over 4 from -3 to 0 plus x to the 4 over 4 from 0 to 2. Okay, so it's going to be f of b would be 0. And then negative 3 to the power of 4. What's negative 3 to the power of 4? So negative 3 cubed is 27. Yes, to the power of 4 is 81. So it'd be negative 81 over 4 plus this one over here would be f of 2 minus f of 0. 2 to the power of 4 is 16 divided by 4. And then minus 0. There's a couple different ways we could do this. You could do common denominators, or some of you would say 81 divided by 4 is 20.25. Like 80 divided by 4 is 20, and then 1 divided by 4 is 0.25. So I'll just show you both ways. The reason why I'm doing that is because 16 divided by 4 is 4. The area total. So this area would be negative 20.25, but the area, that's the net area, so the total area is 20.25 plus 4, so 24.25 units squared. So type this one into your calculator because you'll get a totally different answer if students don't understand about separating it. So students that don't understand will type in math 9. And if you try to integrate from negative 3 to 2, and we're integrating x cubed with respect to x. Okay, I know that overall there's going to be a net negative area. So overall, there's a net negative area of negative 16.25. You could get the answer on your calculator if you separated it into two separate integrals and then you did your negative. So if you changed your bounds, right? So negative math 9, and you did from negative 3 to 2, x cubed. We figured out this area. Oh yes, it'd be to 0, sorry, because we're doing two separate, yes. And then you would add your second area from 0 to 2 to get your answer. Okay, so just split it up. That's the lesson.